One of you please take up the revision.
Ma'am, can I?
Yes, sure.
Okay, ma'am. Points to remember. Simple pendulum. Number 1. A simple pendulum consists of a small metallic ball called bob, suspended from a rigid stand by a thread. Number 2. When the bomb of the pendulum is released after ticking it slightly to one side, it begins to move to and fro. The to and fro motion of a simple pendulum is an example of an oscillatory or a periodic motion.
Okay. So this is the pendulum. Now I take it to this side and I leave it free. What will happen? It will swing over here and again it will go back on the other side. It will go to the other side. Yes? So
Yes.
this is to and fro motion. What it is called as? To and fro motion. So it goes here, again it comes back, again it goes up, again it's come back, again it goes here. So it keeps on swinging from one end to other end. And this one is the mean position, the center one. This is the mean position. You got my point? So it
Yes.
will come here and then it will go back. So it will come to the mean position and then go back to the other side, right? So this movement is called as to and fro movement. And the object which is swinging, which is tied at the end of the thread is called as bob. What it is called? Bob. So this is bob. You see this red one? The one which I am showing? This is bob. Okay? So bob is tied at the end of the string and that is behaving like a pendulum, moving to and fro, swinging from one end to other. Any problem?
No.
Okay. Again, the same thing, we will be doing it again. Please read. It's a revision part, okay? And if you agree with me, you let me know.
Ma'am, can I read?
Read.
Yes, sure, beta.
Ma'am, can I read Gabrani
All of
Sakti?
you will get chance, beta. One who is reading right now,
Simple pendulum. A simple pendulum has a small metallic bob suspended from a strand by a thread. If the bob is taken to one side and released, it moves moves to and fro. The
beta,
two
there's a comma.
and
After release, there is a comma, isn't it, beta?
yes,
And
the
whenever there is a comma, what we should do? Whenever there is a comma, what we should do? Hello?
Yes.
Yes, what we should do? We should pause, isn't it? We should not stop, but we should pause. But you did not. So now learn from today that whenever there is comma, you have to leave a pause and then continue. How you should read, beta? If the bob is taken to one side and released, it moves to and fro. This is how you should continue. Is it clear, beta?
yes.
Yes.
Read it again.
If the bob is taken to one side and released, it moves to and fro. The
How does it look? Better? So you can understand the meaning. When there is a comma, the meaning is understood. You got it?
yes, the
Yes.
to and fro motion of the simple pendulum is called periodic motion or oscillatory motion.
Okay. So now this to and fro movement is called as by two names. One is periodic and the other one is oscillatory motion. So if I say oscillatory motion and if I say periodic motion, you should not be confused because both the motions are same. From this slide, did you understand? This note.
Yes.
Okay, so if I say oscillatory motion, that is equal to periodic motion. Am I right? Is equal to to and fro motion. So there are three motions, to and fro, periodic is equal to oscillatory motion. Any problem so far?
No.
Okay.
No.
Thank you, Peter. Thank you. Now see over here. So this is a pendulum, right? You see the pendulum, Peter? This is the thread and this is the metallic bob which is tied to one end of the thread. This is going to behave like a pendulum. How? Let's see. This is the original position. Okay? Then it is taken to one side. Then it comes back. Again it goes over here. Am I right, beta? Again it
Yes.
comes back. And again it goes up. Yes or no? You can see the arrow. How is it moving? Can you see the arrow?
Yes.
Yes. This is called as to and fro movement, which is known as periodic, which is known as
Periodic.
oscillatory. Got it? All of you?
Yes. Yes.
Nicely?
Yes.
Okay, no doubt, beta?
Yes. No,
Okay.
ma'am.
So we have understood this much.
No, ma'am.
So what is this? Points to remember. What is showing? Can you tell me? What is it, beta? There's nothing written over here. What you can explain? Hello? How do you explain? Can anyone explain, beta? Just
Yes,
looking at
ma'am.
the picture. Can any one of you explain better? Hello? Can anyone explain better what is shown in the picture? Girls, can you hear me?
Yes, ma'am.
Yes. Can you explain better?
Maybe your voice is cutting.
It will become okay. Don't worry. Can you hear me properly?
Yes.
Yes? Okay. What I'm asking you is what is shown in the pic? And can you
Pendulum.
explain? Exactly. Very good. Pendulum. Now, what is shown better over here? It is on one side, isn't it?
Yes.
So that means it will come here, then it will go here. Yes or no? So we
Yes.
have pulled the pendulum onto one side. It is not in the median portion. It's not in the original position, but it is pulled onto one side for the swing. Because until it is pulled, it will not swing better. If I keep it like this, do you think it will move? No. So to make it move, we have to bring it to one side. Yes or no?
Yes.
Okay. Then only we will have this motion, to and fro motion. Am I right?
Yes.
Okay. Now what is this? Make it
Bob.
fast, better. This is a bob. Again,
Center.
the pendulum. But where it is? The position?
Center.
Center. So it is at the central position. So this is original position. What it is, beta? O. This is the original position at the center. And what is this? Now you understood the condition, the way the bob is moving?
Yes.
Please put off your mic. Someone's mic is on. Thank you. So now it has gone to the other position. So we started from here. We started from here. And then we saw the center position, and now we are going to see the to position, and this is fro position. Yes or no?
Yes.
So I've shown you all that movement of the bob. What it is doing? It is doing oscillation. Please continue.
Ma'am, can I read?
Oscillation. Oscillation.
Who
When the
wants to
bob
read better?
moves.
Yes.
Ma'am, can I read?
Yes, better. If you finish one slide, then let others take up the another slide. Okay, better? Thank you.
Oscillation. When the bob moves from the mean position O to A and to B and back to O, it is called one oscillation. When the bob moves from one extreme position A to the other extreme position B and back to A, it is called one oscillation.
Just a moment. Now this is bob. This is mean position O. You agree?
Yes.
Hello? Okay.
Yes.
Then it comes here. It is the position A. You agree?
Yes.
Okay. Then it comes here. Then how it moves? It moves like this, and then it moves like this. So now it comes to this position, which is B. You agree, beta?
Yes.
Yes.
And again, so it is going from here, from O, it's going to here, then it's coming back, then again it's going to B, and again it is coming to O. So how many movement? This is one movement, then this is two movement, then three movement, and then four movement, which is coming back to O. So there are four movements. That becomes one oscillation. What it becomes, beta?
One
One
oscillation.
oscillation.
One oscillation.
Okay. Next one, when the bob moves from extreme A to extreme B, so it goes here and then again it comes back. So A to B and B to A. That is again called as one oscillation. What it is called, better?
One oscillation.
So you understood now? So A to B and B to A. That is one oscillation. All of you understood?
Yes.
Yes.
Okay. Now we'll come to know what is time period. Yes. Read better.
Time period. The time taken by the pendulum to complete one oscillation is called its time period.
Okay. Now what is one oscillation, beta? A to B, agree, beta? And B
Yes.
to A. Yes or no?
Yes.
So this is one oscillation. You agree with me? How
Yes.
much time is taken? That becomes time period. What it becomes? Time
Time.
period. The time taken to finish one oscillation, the time taken to complete one oscillation is called as time period. Any problem?
No.
Is it easy or difficult?
Easy.
Easy. Good. Thank you for making me happy. Now we will again revise it. So whatever we did, we will do the revision. Yes,
Ma'am,
please
can I read?
continue. If you have read it earlier better, then you should not allow others to read. Okay, and if they are not taking up the charge, then you will continue. Okay, beta? If anyone wants to read, please.
Ma'am, can I read?
Sure, beta. Give me your name and start so that I know who is reading.
Ma'am, can I read?
Yes, but give me your name and then start reading.
Even Fatima.
Oven, okay, Oven Fatima, you start reading. And then Rajani Sakina, you will take the next slide, okay? Okay, Oven
Points
Fatima,
to
start.
remember.
one oscillation, the pendulum has said to have completed knee
One. One.
oscillation when its
One beta.
bob moves from one extreme position A to the other, from one extreme position A to the other extreme position B, and comes back to A.
So we know this oscillation. All of you agree? What we
Yes,
say
ma'am.
is one oscillation that from extreme A it goes to B and then again from B it goes to A. So that complete swing to and fro is called as oscillation. Now we'll see what is time period. So all of you agree with me?
Yes.
Yes, ma'am.
Yes.
Fine. So now we'll see what is time period. We are just revising it better. Remember. Say.
Time period. Time taken by the pendulum to complete one oscillation is called its time period. Time
So
period
we'll say
can be
that
calculated by the relation
2, say 2 pi nu. What it is? 2 pi nu. You don't have to read this. Just leave it because it's not in your syllabus. So we'll not do the calculation of time period. We'll just know what actually is time period. So what is time period, beta? It is the time taken by the pendulum to finish or to complete one oscillation is known as time period. Okay. Now we'll do one activity to find out the time period of a simple pendulum. Yes, beta. Start reading. Rajani Sakina.
Yes, ma'am.
Yes. Start reading, beta.
Set up a
There's
simple
there's disturbance, beta. Can anyone else start reading, beta?
Ma'am, can I?
Okay.
Ma'am, can I?
Give me your name, please.
Lakhani Zainab.
Hello.
Lakhani Zainab.
Ba.
Okay, Lakhani Zainab.
Set up a simple pendulum with a thread of length about 1 meter. Move the bob
Beta,
to
there's a
one
full stop.
side.
I just pointed it out that you have to use the punctuations properly. There is a full stop and you are not even stopping. Be careful, beta. I'm very, very particular about it. When there's a full stop, you have to stop. Read it again.
Set up a simple pendulum with a thread of length about 1 meter. Move the bob off one side and release the
Two.
bob.
No, it is two. It's not off. Read properly, beta. You're just changing the meaning.
Measure the time taken to complete 20
When I
oscillations.
stop you, you have to reread it. Hello. I stopped you at move the bob and you said off one side. I said it's wrong. So you have to read the sentence again. Do you understand?
Yes.
Yes. Do it again.
Move the bob to one side and release the bob. Measure the time taken to complete 20 oscillations using a stopwatch or stop clock. Record the observation in the table. Repeat the activity 3 times and record the observations. Time Find the time taken for one oscillation. The
Okay.
time
Now this
period
much.
is nearly the same in all cases.
Okay. Now this much you have understood. What are we doing? We are taking a simple pendulum. So we make an experiment with a simple pendulum. So how much length of thread will be? 1 meter length. And we will attach the bob to one end of the pendulum. We will pull the bob to one side and release it. And then it will keep on moving. How many oscillations are we supposed to take? 20 oscillations. So that means from here and then here. This, how many times we have to take? 20 times. You
20.
understood? This is one
Yes.
time. This is one time. Remember, this is one oscillation. So this sort of moving to and fro 20 times we have to take. And with what we will measure or calculate, we will have a stopwatch or a stop clock. We make a table and read this or record these observations. We will do the same observation three times. 20 oscillations we will measure again three times. The same activity will be done thrice. And we have to find out the observation. What you will find? That the time period remains the same. You understand?
Yes.
Yes.
How many times you take? Doesn't make any difference. The time period remains the same. If you take 10 times also, then also time period remains the same. Any problem?
No.
Time period does not change. Look over here. Here from A to B and from B to A. You understood? This is one oscillation. This is one oscillation. First we will say, for example, we take 5 seconds. Okay?
Yes.
So in all you will get 5 seconds. Because we are taking only 20 oscillations. It remains the same for each cases. Now we'll work on time and speed. Please start.
Ma'am, can I read?
What's your name, beta?
Misbah.
Misbah. Okay, beta.
Units of time and speed. The basic unit of time is second.
You agree?
The-
Do you agree? What is the unit of time, beta? It is second. What is the symbol?
S.
S. What is the symbol, beta? S. So all of you agree with this, beta? With Misbah?
Yes.
Okay. Then this is the smallest unit. Hello, beta. Remember, this is the smallest unit of time. Now we are going to work with the larger units of time. Yes, Misbah, continue, beta.
The larger units of time are minutes, hours, etc.
Okay. So what are the larger units of time? Minutes, abbreviated as MIN. Hours, abbreviated as H. Is this clear?
Yes.
Yes.
All of you? So this much you have understood? The time, smallest unit is second, largest units are minutes and hours. Okay. Now we are going to work on speed. Start with it.
A basic unit of speed is meter per second. A large unit of speed is kilometer per hour.
Okay. Similarly, speed is equal to distance upon time. This much you know? The formula of speed, beta?
Yes.
You know the formula of
Yes.
speed? I think in maths you must be doing. It's distance upon time. What is distance, beta? It is meter or kilometer, isn't it?
Yes.
Yes.
And what is time? Hour, minute, or second. Agree?
Yes.
Yes.
Yes? Okay. So what it is? Speed is equal to, if I say meter, then which unit it will take? The smallest unit? Second. If I take the larger unit, this kilometer, what is the larger unit of time, beta? Hour.
Hour.
You got it now? You understood now? The
Yes.
smallest unit of distance is meter. The smallest unit of time is second. The largest unit of distance is kilometer. The largest distance of, not distance, the larger time, the unit is hour. So this is how we have to relate. Any props?
No.
Okay. All of you understood better regarding speed?
Yes.
Now we will see how people used to measure time, how people used to find out regarding time, because they did not have watch or clock or something of that sort. How were they able to find out regarding time? Read better.
Ancient time measuring devices. Some ancient times measuring devices were sundials,
Dials.
water
Read
clocks,
it again. Sundials.
sundials,
Sundials. Then,
sundial, water clocks, and sand clocks.
okay. So these were the three very old measuring devices for time. First one is sundials. See over here? This is sundial. So this unit, how it gives the shadow. Can you see the shadow over here?
Yes.
The shadow. That shows the time. And you can see these all are in Roman numerals. Can you see this? All are in Roman numerals. See, all these are Roman. See the number. Third, fourth, five, six. These are all Romans. You understand?
Yes.
Okay? Yeah. So the shadow which falls, you can see the shadow which falls, show the time of that particular era. The second one is water clock. You see this? This is the water clock. And the
Yes.
third one is sand, sand clock. This is hourly glass. What it is? Hourly. It takes 1 hour to fill this one. This will get emptied and the whole glass will be filled by the sand. It takes 1 hour. So you can measure 1 hour by using sand dials or sand clocks. You understand?
Yes.
So three. First one is sundial, this is water, and this is sand dial. You understand?
Yes.
Now we'll see how to measure speed. Yes, better start.
Measuring speed. The speed of an object can be measured if we know the distance covered by the object and the time taken.
So you
Example.
agree? Just a moment. So what for speed? What is required? Distance and what is required, better?
Time.
Time. If these two are given, then and then only we can find the speed. Otherwise, we cannot find the speed. So, what is important? Distance and time. Yes, start. Example.
If a car covers a distance of 100 kilometers in 2 hours, then the speed of car is distance covered 100 kilometer, time taken 2 hours,
Okay, just a
distance
moment. Just a moment. What is given here? Distance of 100 kilometers, right? Time, what is given? 2 hours. So, same thing we have written over here. What do you say? Yes or no?
yes,
So
Yes.
we have written down distance covered 100 kilometer and time taken 2 hours. So it is given. This is given, right? So we wrote it down. Now what is the formula of speed, beta? What is the formula of speed? Hello.
Speed, distance upon time.
Exactly. So what is the speed? The formula of speed is distance upon time. So
Right.
what we have to do? We have to put the values of distance upon time. What is the value of distance, beta? 100. What is the value of time? 2. So what we got? 50. This was
kilometers.
kilometer and this one was hour. So what we wrote? Kilometer per hour. Any problem?
No.
No.
Now next.
If we know the speed of the car and the time, we can find the distance covered by it.
For example, we know speed is equal to distance upon time. Now speed is known, time is known, we can find out distance. How? Distance is equal to speed into time. This is what we got. Yes?
Yes.
All of you agree?
Yes.
Yes.
So what we got? 50 into 2 is equal to 100 kilometers. So did we got the distance 100 kilometer beta?
Yes.
This was given already. You understood? Okay. Now next.
If we know distance covered by the car and the speed, we can find the time taken.
For
Time.
example, just a moment beta. Speed is equal to distance upon time. Right? So I can put time over here. Can I put? Therefore, time is equal to distance upon speed. Can I do that? I took this on top and I put this one down. Can I do this? It's maths better.
Yes.
Can I do this or not? If you permit me. Can I or can't I? I'm teaching you maths better. Yes, tell me, can I do it or not? Hello? Did you understand what I did?
Yes, ma'am.
You understood? Or should I do it again? Girls, should I do it again, beta? Hello?
Yes.
Yes.
Should I do it again? Okay. See, speed is equal to distance upon time. Do you agree?
Yes.
Yes.
Yes, ma'am.
Do you agree, all of you?
Yes.
Yes.
Okay. What I will write? I will cross multiply. Can I do that? Cross multiplication?
Yes. Yes.
Okay. So
Yes.
distance is equal to speed into time. Can I do this?
Yes.
I can take this on the other side. So this is left hand side and this is right hand side. So I'm taking right hand side to left hand side. So I can write this S into T is equal to D. Can I do this?
Yes.
Yes. So T will be D upon S. Yes? Yes or no?
Yes.
Think you got any problem?
No.
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 All of you understood?
Yes.
Yes.
What earlier what I did shortcut. So maybe you do not understand, okay? So whenever this sort of things happen, you can ask me to redo better. Feel free to ask me as many times as you wish. Okay?
Okay.
Clear everything.
Okay, ma'am.
Don't take
Yes.
a simple, even if you think that it is silly. Your questions are silly, doesn't matter. Ask me. You got my point?
Yes.
Yes.
Yeah. So don't hesitate at all, beta. So now this much is okay. So what we found, 100 upon 50. What is the time?
2
2
hours.
hours. What was given? 100 kilometer was given. This is the first distance. And the second, what was given? Time. We got both the things. Got my point?
Yes.
Yes.
This our question is, our answer is correct. Yes?
Yes.
Any problem regarding the numerical?
No, ma'am.
All of you understood the numerical better?
Yes.
Now points to remember. See, everything is revised now. Points to remember is, this is the revision part.
Ma'am, can I read?
Yes,
Ma'am, can I
please.
read?
next one you take up. Okay? Let
Ma'am,
her
can I?
continue.
Ma'am, can I read?
Ma'am, can I?
Name, please, name.
Zainab
Lakhani.
Rupani.
Zainab.
Zainab
Zainab
Rupani.
Rupani. Okay, Zainab Rupani. Start.
Okay, ma'am. Points to remember. Unit of Points to remember. Unit of time and speed. The basic unit of time is second. Its symbols is as or second. The basic unit of speed is m or s. Speed.
Meter per second. Hello, Zainab. How you have to
Yes.
read it, beta? Meter
Meter per
per
second.
second. Okay? Now stop
Meter.
for a while. First, we'll take up time. What we had learned earlier, that the time unit is second. That's the basic unit, the smallest unit. What is the symbol? S. We are giving another extra is SEC, that is second. You understood? S is also second, SEC is also second. Agree with me,
Yes.
all of you?
Yes.
Yes.
Yes, ma'am.
So what is basic unit of the lowest? What I am talking about basic is the lowest unit beta. So which is the smallest? Meter per
Second.
second. What? Meter per second. Say it again beta. Janab. Meter
Yes, ma'am.
per
Meter per
second.
second.
Understood
Second.
now? This is how you
Yes.
have to read it. Okay? Fine.
Okay.
Now, how to find out the speed? How to
Ma'am, can
find the
I read?
speed? No, let her continue, beta. Let Zainab continue. I will give it another
Speedometer.
slide to you. Yes. So we use speedometer. What we use, beta?
Speed.
Speedometer to learn about speed. Please read, beta.
Speedometer. It is a device to record speed. It records the speed directly in kilometer per hour.
Now this is the largest unit, remember.
Yes.
Speedometer is in our car, trucks, lorries, big vehicles. So speedometer is already in the dashboard. When you're driving on the steering wheel, next to the steering wheel on the dashboard, you have got speedometer, which records the speed that you are driving your vehicle. You understand?
Yes,
And
ma'am.
which is the largest unit that we are going to work on is kilometer per hour. We'll not use meter per second because the distance that we are covering is in kilometers, isn't it?
Yes.
It is not in meters, but we are covering in kilometers.
Kilometer.
Okay, the next one is better.
Odometer. It is device to measure the distance covered by the vehicle.
There's another device on the dashboard, a unit which is called as odometer. Now, speedometer is finding out the speed, right? And odometer is finding out the distance. And then what we find beta later? We find, what do we find beta?
Average.
Average. Hope you understood why we talk about the average of this car is better than the average of the other car. Don't we say that?
Yes.
Yes. So this is how to find out the average of a particular vehicle. Any problem?
No.
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 Let's do the same thing again. Please, who wanted to read better?
Ma'am, can I?
Can I?
Yeah. What's your name?
Lakhani Zainab.
You have already read it better, isn't it? Let the chance go to someone else who has not participated. Yes, who wants to read better?
Ma'am, can I?
Yes, tell me your name.
Almas.
Okay, Almas, start better.
Speedometer. Speedometer is a device which measures the speed of vehicles in kilometer per hour.
You agree?
Odometer. Odometer
Just
is
a
a
moment. When
device.
I stop, you have to stop. I just said something. Did you hear me what I said? That do you agree with what is written
Yes.
in speedometer?
Yes, ma'am.
Yes? Fine. So which unit are we taking? Kilometer per hour, largest unit. Okay. Now next one is
Odometer. Odometer is a device which measures the distance covered by a vehicle.
Okay, so what we are finding out? Distance. The distance has to be in kilometer. Yes or no?
Yes, ma'am.
Good.
Yes, ma'am.
Now, what is the extra in this slide? It is the pick. Can you see the speedometer over here?
Yes.
Yes,
This is the
ma'am.
speedometer. So, see how what it is showing here? 100. What it is showing here?
Yes.
100.
100.
Isn't it? Or this is 100 is mile per hour. What it is? mph. And the bottom one, here bottom one is kilometer per hour. So what it is showing actually over here is 140, 160. This is 160 kilometer per hour. What it is showing better? Your car is
160
driving.
kilo
Yes, your
per
car
hour.
is running at 160 kilometer per hour and 100 miles per hour. You understand? You understand?
Yes, ma'am.
Okay, fine. Now over here we have both speedometer and odometer. You understand? You've got speedometer and odometer, both are in the same unit. Okay? Hello.
Okay, ma'am. Okay, ma'am.
Okay. Same way. Points to remember. So this is your dashboard of the car. So you've got both the speedometer and the odometer. See here it's written kilometers. Can you see this here in the center?
Yes.
This center. So this shows that this much of kilometers you have traveled. And this one is kilometer per hour. That means your car is driving at that speed. You understood better?
Yes,
Yes.
ma'am.
Now points to remember. See everywhere we are revising
Ma'am,
it.
can I read?
Sure, better. What's your name?
Fatima.
Okay, Fatima. Please go ahead.
Points to remember. Graphical
Representation,
representation of data. We can represent the data in
pictorial.
pictorial form by three
Okay. Three
ways.
ways. Okay. Which are the ways? Let's see.
First, first bar graph, second pie graph, and
Pie
third
chart.
line graph.
Okay.
Pie
So these are
chart
the ways.
and
Pie
third
chart.
line graph.
Line chart. Okay. Good. Now, how do we show the distance traveled and the speed? How can we show that? By showing datas. And these datas can be shown pictorially by picture. What is pictorial beta? Picture. Got it now? So from pic it has come pictorial. Three ways. What are the ways? First is bar graph. What you see is bar graph. This is bar graph beta. This is bar graph. You can see all these are bars. 1, 2, 3, 4. These are all bars. You got it? You understood?
Yes.
One is,
Okay,
it
ma'am.
looks beautiful, isn't it? It looks beautiful. See?
Yes.
So, this is bar graph. This is pie chart, which is in circular. This is called as pie chart. What it is called, beta?
Pie chart.
Pie chart. Okay. And the other one is line graph. So you can see this. This one is line graph. Can you see this? So this is pie. This is line chart. You understood now? So everything is in line. Can you see this? All these are lines. So that is lines. You should know what are the types of graph. That's why I've personally, uh, uh, purposely rather, taken all this type of graphs. So you should have an idea that there are so many types of graphs which will come in maths as well. How to relate, how to show, how to show the percentage. It's been depicted in these forms. Okay, beta? Okay?
Okay, ma'am. Okay, ma'am.
Ma'am,
You will
lecture is over.
just one, can I take your 1 second, beta? This is the last
Yes,
slide
ma'am.
we will do. Okay. Please take up this slide, beta.
Okay, ma'am. Points to remember. Motion of an object can be represented in pictorial form by the distance time graph.
Okay,
First,
this should
the
be
distance
represented, don't you think so? Hello, this should be represented, don't you think so, beta?
yes, ma'am.
Yes, it should be represented, no? It is written wrong. Doesn't matter, we should understand that. So we will show distance time graph and we can show the motion in the pictorial form. Say, read. Hello.
First, yes, ma'am. The distance time graph for the motion of an object moving with a constant speed is always a straight line.
It's always a straight line. Can you see this over here? So it's a distance
Yes, ma'am.
time graph. So it's a straight line. That what it shows. It is a constant speed. What it is? Constant speed. Understood? It is going a
Yes,
straight line.
ma'am.
In this case, what is this? Earlier, it is going slow and then it increases the speed. So it is accelerating. Yes or no?
Yes.
Yes, ma'am.
Here, it is a straight line like this. That means at 1 hour, the vehicle was here. At 2 hour, again the vehicle was here. At 3 hour, again the vehicle is. What it shows that it is not moving at rest. Yes or no?
Yes.
All of you understood? So if I show you a graph, you'll be able to understand what it is all about, isn't it? So
Yes.
you have understood all these three graphs. The first one is moving at a constant speed.
Yes, ma'am.
Second one is increasing the speed. And third one is at rest. It is not moving. Any problem?
No, ma'am.
So I hope you have
No,
understood
ma'am.
it nicely, today's lecture.
Yes. Yes.
Okay, if at all you have any problem, just let me know, beta. So I'm thankful to all of you
Okay,
for
ma'am.
being patient, for being a
Bye, ma'am.
participant.
Bye, ma'am.
Bye,
Bye,
beta.
ma'am.
Thank you,
Bye,
thank you.
ma'am.
Bye, beta.
Bye, ma'am. Have a good day.
Same to you, same to you.
Bye, ma'am.
Bye, beta.